Our last unit of this quarter is about circles, so we're really going to look at something very different from what we've been looking at, but never fear, there are still triangles, and so a lot of our triangle rules, and we can still build quadrilaterals and other shapes inside of our triangles. So everything we've been working on may still come into play. So as always with geometry, we have to go in and make sure that we're talking the same vocabulary. So we need some new vocabulary words for circles. So first of all, we have to talk about how do we name a circle. And we always name a circle by the center. So we name with the center point, and we actually use a circle with a little dot in it, circle X. That is how we name it. If the center was marked P, we call it circle P. So pretty simple to name. A couple of interesting lines in a circle. The segment that goes from one point through the center to the other is the diameter. So we'll say side to side. Side to side through center. That's the key. And then we have the one from the center out, which is our radius. And that is the center to the side. And those are probably review terms. And we know that these two are related by the fact that 2 times the radius is the diameter, because if we came in and thought about this half, and this half is 2 radius. So that's all review. Circumference is something that should also be review. That's really the perimeter of a circle. We just have a different name for it. And we find the circumference by taking pi times diameter. So if you know the radius, you can find the radius, turn it into the diameter. If you're given the diameter and you want the radius, you know you can move back and forth between those formulas. Just as a reminder, area of a circle is pi r squared. One thing that we are going to talk about from time to time in this unit is exact answers. And then we really just want you to leave pi in the answer. Don't go ahead and multiply and round. So it's actually a pretty easy way to find your answer and be done. So that's all review. So some new information would be a minor arc. And this is, we're talking about a piece along the circle. So if we have circle P here. Circle P, and I would have some points like A and W and X on the outside of my circle. A minor arc is less than 180 degrees, and we name with the endpoints. So much like a segment, so we name with the endpoints. So AW is a minor arc, and we put a curved arc over top of it. So it's not a segment. We don't use a straight line. We use that curved line to indicate it is an arc. A major arc, if I have circle R, and I would have W, X, and Y points on my circle. A major arc is greater than 180, and we are going to name with 3 points. Ends and 1 in the middle. That tells us what direction to go. So for example, we would say I want to name arc W, Y, X. And then I know to go this way around. It's like naming an angle in the fact that it tells me what direction to go. Aside from this, a semicircle equals 180, and that goes along a diameter. So if I have my circle, and I have X and Y and W, I can talk about the semicircle arc of Y, W, X, which equals 180 degrees exactly, because it's half the circle. So if you see that, we know that. So arc length is a new term. And what we're talking about with arc length, and we always indicate this as a capital L, this is a fraction of the circumference. So we are talking about what fraction of the circumference. Okay, so it's not area, it's what piece does my arc cut off. My angle cuts this piece of the circumference, and I'm trying to calculate that. So that formula is the length, arc length, is equal to the measure of the angle over 360 times the circumference, which is pi times diameter, and I'm just going to put that over 1. Now that measure is this angle right here, because the measure over 360, that's the fraction of my circle, 360 all the way around. That little angle right there, how much is that cutting off? And we'll see some examples in the next video. Sector area is a similar concept. I want to know what fraction of the area is right there. Not the area of the whole circle, but what fraction of the area. And so we say the sector is equal to, again, the measure over 360, because that gives us that fraction, times the area of the whole circle. And we are making that measure, that little central angle right there. So speaking of central angles, the central angle has a vertex at the center, and the measure of the angle equals the size of the arc. So if this is an 87-degree angle, this is an 87-degree arc. This we're going to cover in section 2, so you can cross that off. The next video has the examples of how we are going to apply this information.